So here we shall solve some more KCET previous year questions on the chapter matrices and determinants. Um, so if you have any questions regarding any steps of the solutions or any other kinds of doubts if you have, then please write us in the comments section. Uh, and and if you feel you have more difficulty in any of the chapters of maths, then please write the name of that particular chapter also in the comments section. Then we shall give more priority on it and solve more and more questions on that chapter, which would be helpful for your KCET exam. And please install our Sapience education application, where we shall upload some important homework questions on every chapter. Uh, so the link of the Sapience education application has been provided in the description. So in this chapter on matrices and determinants, the first question is that 2a plus 3b, the matrix 2a plus 3b is given as 2 minus 1 4 3 2 5, and a plus 2b is given as 5 0 3 1 6 2. Then b is equal to how much? Okay, so here suppose we multiply with 2 in the second equation on both sides, then we will have 2a plus 4b, that is equal to 2 into, we have to multiply all the elements with 2, so that will be 2 5s are 10 0 6 2, then 12 4. So therefore now the matrix B we can find like this: 2a plus 4b minus of 2a plus 3b. Since why, then we will get 2a will cancel and 4b minus 3b will give us b. So this will be 10 0 6 2 12 4 minus 2 minus 1 4 3 2 and 5. So that will be equal to, now 10 minus 2, that is 8, 0 minus of minus 1, that is 0 plus 1 1, 6 minus 4, that is 2, 2 minus 3, that is minus 1, 12 minus 2, that is 10, 4 minus 5, that is minus 1. So it means that the option A is the correct answer. So no, sorry, option B is the correct answer. Option B is the correct answer. Then question number 2 is told that if the order of matrix A is 2 cross 3 and the order of matrix B is 3 cross 2 and the order of C is 3 cross 3, then which of the following is not defined? So the matrix, so in the option A, the matrix CB will have the order of the matrix CB will be, so C is of the order 3 cross 3 and B is of the order 3 cross 2. So CB will be of the order 3 cross 2 and A transpose will be of the order, A transpose will be also of the order 3 cross 2. So they are of the same order, that's why they can be added. So CB plus A transpose is defined. Since the order of CB is same as the order of A transpose, and BAC, the order of the matrix BAC. So B is of the order 3 cross 2, A is of the order 2 cross 3, and C is of the order 3 cross 3. So now BA will be of the order 3 cross 3. Then so BA into C is defined. So order of matrix BAC will be 3 cross 3. So BAC is defined. BAC is defined. And then C into A plus B transpose whole transpose. So now A, the order of matrix A is 3 2 cross 3 and order of matrix B transpose, that is also 2 cross 3. So they can be added. Now order of matrix A plus B transpose whole transpose, that will be 3 cross 2 and order of matrix C is 3 cross 3. So it means that matrix C can be multiplied with A plus B transpose whole transpose. Since A plus B transpose whole transpose will be of the order 3 cross 2. So therefore, the order of the matrix C into A plus B transpose whole transpose, that is equal to 3 cross 2. So that is defined. So C into A plus B transpose whole transpose is defined. Then C plus A plus B transpose. So A plus B transpose will be of the order A is of the order 2 cross 3, B transpose of the order 2 cross 3. So A plus B transpose will be of the order 2 cross 3. Now C is of the order 3 cross 3. So C is of the order 3 cross 3 and A plus B transpose is of the order 2 cross 3. So it means that C into A plus B transpose is not defined. So option D is the correct answer. Then it is told that if the matrix A is 1 minus 3 2k and A square minus 4a plus 10i, A square minus 4a plus 10i, that is equal to A, then we have to find k. Then we have to find out k. Now the matrix A square will be A into A, that is 1 minus 3 2k into A square is actually A into A. So that is 1 minus 3 2k. So that will be equal to, it is 1 ones are 1 minus 6, this is, and this is minus 3, then minus 3k, then this will be 2 plus 2k, and this is minus 6 plus k square. So this will be minus 5, then minus 3 into 1 plus k, 2 into 1 plus k, then this is k square minus 6. So now therefore A square minus 4a plus 10 into I, that is equal to A. Then we have to find out the value of k. Now A square is minus 5 minus 3 into 1 plus k into this is 2 into 1 plus k into k square minus 6, and this is minus 4 into A. 4 into this is A. A is 1 minus 3 2k, and then plus 10 into I. I is 1001. That is equal to A. A is 1 minus 3 2k. Okay. So then we have to solve it. Therefore we can write it as this is minus 5. So from here we can see that this is minus 5 minus 4 plus 10. Then this is 2 plus 2k. So from here we can say that 2 plus 2k minus 4 to the 8, then plus 0, that is equal to 2. So therefore I can say 2 and 2 will cancel. So 2k equal to 8. So k is equal to 4. So k is equal to 4. So it should be 4 only and not 1. Since why? If I tell that k square minus 6, from here we can also have like k square minus 6, then minus 4k, minus 4k plus 10, minus 4k plus 10, that is equal to k. So from here we can get k square minus 3k plus 4, that is equal to 0. So from here we get k minus 4 into k plus 1, that is equal to 0. So from here I can get k is equal to 4 or k equal to minus 1. But if I take k as minus 1, then this will become 0. So then we have 0 minus 8 then it can't be equal to 2. Okay, so it means that option C is the correct answer. It means K should be equal to 4 and not 1. Option 3, yeah, question 3, option C is the correct answer. Then the value of this mod of means we have to find the determinant of x plus y plus z plus x, then x, y, z, then x minus y minus z, and z minus x. So we have to find the determinant of this. So you can simply add the first row with the first row with the last row, or we can yeah, first row and the last row means we are doing r1 goes to r1 plus r3. So if we apply this row operation, then we will have, so since if we apply the elementary row operations in, then the value of the determinant remains unchanged. So value of a determinant, the rule is value of a determinant remains unchanged under elementary row operations, means unchanged under the elementary row operations or column operations. So here if we add first row and the third row, then we will get, this is 2x, then this will be 2y, and this will be 2z, and then this is x, y, z, and this is x minus y minus z, z minus x. Then from here 2 I can take outside as common. And from the first, okay, so 2 if I take from the first row, then the first row and the second row are identical. First row and second row are coming identical. That is why the value of this determinant will become 0. This 2 into 0, that is 0. So option D is the correct answer. Then in question number 5, it is told that if the matrix A is this 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1, and 10b is equal to 2, 4, 2, 2, minus 5, 0, alpha, 1, minus 2, 3, and b is the inverse of A. So b is equal to A inverse. Then the value of alpha is how much? So if b is A inverse, this is given in the question, then we know that A into A inverse, that is equal to I. So it means that A into B, that should be equal to I. Now it means that A into 10b, that should be equal to 10 into I, 10I. So therefore A into 10b, that is equal to 10 into I, means 10 into the matrix, the identity matrix of the order 3. That is 1, 0, 0, 0, 1, 0, and 0, 0, 1. So A into 10b, that is 1, minus 1, 1, 2, 1, minus 3, then 1, 1, 1, into 10b. 10b is 4, 2, 2, minus 5, 0, alpha, 1, minus 2, 3. So that will be equal to, this matrix will be, this will be 10, 0, 0, 0, 10, 0, 0, 0, 10. So we can multiply the first row with the third row, and then we can say that it is the element of the first row and third column, that is 0. So from here I can say that 1 into 1 into first row into third column, that is equal to the element in the first row and third column here. So this will be 4, that is 2 minus alpha plus 3, that is equal to 0. Means that alpha is equal to 5. So alpha should be equal to 5. So option C is the correct answer. Okay. Then, so if you are unable to understand any of the steps of the solution, in this chapter of matrices and determinants, then please write us in the comments section. We'll clarify those doubts in the subsequent videos. Then in question number 6, it is told if the matrix A is singular, 0x, 16, x, 5, 7, and 0, 9x. So the rule is that if the determinant of the matrix A, if the determinant of A is equal to 0, then the matrix A is called as singular matrix. Then A is a singular matrix. So now here we have to find the possible values of x. So x will be equal to, so means we have to find the determinant of A. Now therefore the determinant of A, that should be equal to 0. It means we have to find the determinant of 0, x, 16, x, 5, 7, and then 0, 9, x, that is equal to 0. So now since we can see that in the first column we have the maximum number of zeros, so we can expand this determinant. So this determinant can be expanded along this first column only. So x is the first, the element in the first column and second row. First column and second row. First column and the second row. So it will be, you can say that it will be minus x into, so we have to then exclude the first column and the second row. Then we have to take the determinant of the remaining part. To take the determinant of the remaining part, that is x square minus 16 into 9, that is 9 6 are 54, that is 144, that is equal to 0. So from here we can say that it will be x into x plus 12 into x minus 12, that will be equal to 0. From here we can say that x can be equal to 0, minus 12, or 12. So option A is the correct answer. Option A is the correct answer. Then in question number 7, if the matrix A, that is equal to 1, minus 2, 2, 0, so here 1, minus 2, 2, 0, 2, minus 3, 3, minus 2, 4, then A into adjoint of A, that is equal to how much? So we know that A inverse equal to adjoint of A by the determinant of A. For any matrix A, for any square matrix A inverse, that is equal to adjoint of A by the determinant of A. So therefore A into A inverse, that will be equal to A into adjoint of A divided by the determinant of A. So which is equal to I. A into A inverse is I. Therefore A into adjoint of A, that is equal to the determinant of A into I, where I is the identity matrix of the same order as that of A. So here I is what? This is the determinant of A into the identity matrix, which is 1 0 0 0 1 0 0 0 1. So now the determinant of A value will be which is 1 into, so if we expand it along the first row, then we will get 1 into 2 4 is 8, minus 2 3 is 6, then minus of minus 2, that is plus, so plus 2 into, then we will remove the first row and second column, and that is equal, okay. So we have to remove the first row and this second column, then it will be 0 into 4, that is 0, minus of minus 9, that is plus 9, and plus 2 into, this will be the, we have to remove first row and third column, and then we have to take the determinant of the remaining part. So that will be 0 minus 6. Minus 6. Okay, so this will be 1. 8 minus 6 is 2. So 2 plus 2 9 is 18. Then minus 2 6 are 12. This will be 2 plus 6, that is equal to 8. So therefore, the A into adjoint of A, that will be equal to the matrix 8 0 0 0 8 0 and 8 0 and 0 0 8. So it means option C is the correct answer. Then we have to find the value of this determinant. The value of this determinant we have to find. So it is xpq, pxq, pqx. So we can expand this determinant along the first row. So if we expand this determinant along the first row, then we will have x into x square minus qx. Sorry, this is q. So x square minus q square. Then minus p into px minus pq, and plus q into pq minus px. This will be equal to x cube minus q square x minus p square x minus p square q plus pq square minus pqx. Okay, so then here what we can do, we can take x minus q as common. So this we can factorize. So this will be x into x plus p, x plus q into x minus q. This will be minus p square into x minus q. This is plus pq into x minus q. So this will be minus pq into x minus q. So this we can write, this will be x square minus x square plus qx minus p square minus pq into x minus q. So this we can factorize it again. So this will be x plus p into x minus p, x plus p into x minus p, then plus q into x minus p, then into I can do x minus q. So if we factorize it, then we will get x minus p into x minus q into x plus p plus q. So option B is the correct answer. Then we have to find the characteristic roots of this matrix. Characteristic roots. So we know that the rule is that for a matrix A, the characteristic equation for a matrix A, the characteristic equation is given as the determinant of A minus lambda I, the determinant of A minus lambda I, that is equal to 0, where I is the identity matrix of the same order that as that of A, and lambda is called the characteristic roots of the matrix. Lambda is the characteristic root of the matrix A. So therefore we have to do the determinant of, so first we have to find A minus lambda I. So A, this is 1 0 0 2 3 0 and then 4 5 6 minus lambda into I is 1 0 0, then 0 1 0, then 0 0 1, that is equal to how much? So that will be 1 minus lambda, then 0, and this will be 2, This will be 3 minus lambda, then 0, then 4, 5, and this will be 6 minus lambda. So it's so the determinant of this matrix should be equal to 0. Therefore, the determinant, that will be the determinant of 1 minus lambda 0 0, then 2 3 minus lambda, then 0, then this is 4 5 and 6 minus lambda. So this determinant should be equal to 0. Now we can expand this determinant along the first row, since it has got most number of zeros, so it will be 1 minus lambda into 3 minus lambda into 6 minus lambda minus 0. So this will be equal to 0. So it means that from here we can see that it will be lambda minus 1 into lambda minus 3 into lambda minus 6, that is equal to 0 also. It means that lambda can be 1, 3 or 6. So these are the characteristic roots of this matrix. So option C is the correct answer. Then question number 10, it is told if A is equal to, if A equals to the determinant of A1, B1, C1, A2, B2, C2, and A3, B3, C3, and the matrix and B is the determinant of C1, C2, C3, and A1, A2, A3, B1, B2, B3. Then it is what? Okay. Then which of these should be satisfied? So now the matrix, so the A we can also write the determinant of, so we can take the transpose of this, then also the determinant would be the same. So that would be also like A1, A2, A3, B1, B2, B3, C1, C2, C3. So here first we can take, first we can interchange the first row. So we can interchange the first row and the third row. Then we will have, that is C1, C2, C3, B1, B2, B3, and A1, A2, A3. Now here we should write that it is equal to negative of this. Since when two rows are interchanged, then the sign of the determinant will change. Now again if we interchange the rows R2 and R3, R2 if I R2 and R3 are interchanged, then again one more minus sign will come, so minus will become plus, and then we will have C1, C2, C3, and A1, A2, A3, and B1, B2, B3. It means that A and B, they are same, so A is equal to B. So option D is the correct answer. And then it is told if the matrix A is equal to 1, 2, 3, 4, then find the inverse of this matrix A. So inverse of the matrix A is equal to the transpose of the cofactor matrix, which is equal to A11, A12, A13, A21, A22. So here A11 is the cofactor of the element 1. So that will be minus 1 whole power 1 plus 1 into M11. M11 is the minor. So we know that Aij equals to minus 1 whole power I plus j into Mij, where Aij is called the cofactor of the element cofactor of the element aij, it means the element of the ith row and jth column, and mij, similarly it is called the minor. It is called the minor of the element aij, where I is the row number and j is the column number. So here it will be minus 1 whole power 2, that is equal to 1 only. So 1 into m11 means we have to remove the first column, first row and the first column. So mij means it is the minor of the element aij. It means it is obtained by removing the ith row and the jth column, by simply removing the ith row and the jth column. We have to remove the ith row and jth column, and if we take the determinant of the remaining part, then we will get the minor of the element aij. So this will be 1 into, so m11, it means that first row and first column we should remove, so that will be 4 is equal to 4, and a21, sorry, a12, that will be equal to minus 1 whole power 1 plus 2 into m12. So this will be equal to minus 1 into m12, means we have to remove the first row and second column, so we will get 3, so that is minus 3. And a21, it means it is minus 1 whole power 1 plus 2 plus 1 into m21 means it is the minor of the element in the second row and first column. It will be minus 1 into, so second row and first column we have to remove, so we will get 2, so that is minus 2. And a22 will be equal to minus 1 whole power 2 plus 2 minus 1 whole power 2 plus 2 into m22. So it is m22, it means that we have to remove the remove the second row and second column and take the determinant of the remaining part, second row and second column, so that is 3, 1 into 3, that is 3. So therefore a inverse will be equal to, this is 4, a12 is minus 3, and a21 is minus 2, and a22 is 3. So 4 minus 2, okay, so a inverse is, so actually it is the adjoint, is the, this we have found, it is the adjoint of the matrix A, and a inverse is adjoint of A divided by the determinant of A, adjoint of A by the determinant of A. So therefore now here the determinant of A, that will be equal to, is 1 into 4 minus 2 is 6, so 4 minus 6, that is equal to minus 2. Now therefore the A inverse which we have to find, therefore A inverse, that is equal to adjoint of A divided by the determinant of A. So adjoint of A, so the determinant of A, that is minus 2, so it will be 1 by minus 2 into the adjoint of A, that is 4 minus 2 minus 3, 3. 4 minus 2 minus 3, 3. This is the A inverse, which is minus 1 by 2 into, so this is minus 1 by 2 into 4 minus 2 minus 3, 3. Minus 2 minus 3. Here actually something may be wrong. Here, A22, A22, it means that M22 means first row and second row and second row and second column we have to remove. So it will be 1. Be 1 actually. Okay. A22 is 1. So the determinant of A is 4 minus 6 is minus 2. Okay. Is 4 minus 2 minus 3 1. Okay. So option C is the correct answer. Then here it is told that if A into adjoint of A, that is equal to 5i, where I is the identity matrix of order 3, then adjoint of A, then the determinant of adjoint of A is equal to. So now the rule is that we know that A inverse, that is equal to adjoint of A divided by the determinant of A. A inverse is adjoint of A by determinant of A. So it means that A into A inverse, that is A into adjoint of A by determinant of A, that is equal to I. I is the identity matrix of the same order as that of A. So A into adjoint of A, that is equal to the determinant of A into I. Now therefore here it means that the adjoint of the determinant of A, that is equal to 5 here. If we compare the given equation and this, so it means that the determinant of A is 5. Therefore if we take the determinant on both sides, then we will have the determinant of A into adjoint of A, the determinant of A into adjoint of A. So A is the I is the identity matrix of order 3. It is of order 3. It means that it will come. So determinant of A into I, that we can write, this is determinant of A 0 0 0 into determinant of A 0 and 0 0 and 0 0 and then determinant of A. So this will be equal to the determinant of A whole raised to 3. So therefore we can say that the determinant of adjoint of A, that will be equal to the determinant of A cube divided by the determinant of A, which is equal to determinant of A whole square. So now here the determinant of A is 5, so therefore the determinant of A whole square, that is equal to 25. So option D is the correct answer. Then in question number 13 it is told that if the determinant of x plus 1, x plus 2, x plus a, and x plus 2, x plus 3 and x plus b, then x plus 3 and then x plus 4, x plus c, that is equal to 0, then a, b and c are in which kind of series? Are they equal, or are they are in AP, or are they are in GP, or are they are in HP? So that we have to show. So now here we can add all the 3 columns here. Here we can do R1 goes to R1, or I can say like R2 goes to R2 into R2. R2 goes to 2 into R2. So then we will have the determinant of x plus 1, x plus 2, x plus a. And here we will have that 2 into 2x plus 4, and this will be 2x plus 6, this 2x plus 2b, x plus 3, x plus 4, x plus c, that is equal to 0. Now what we can do, we can So R2 goes to R2 minus R1 plus R3. R2 minus R1 plus R3. So it means we can write this is the determinant of x plus 1, x plus 2, x plus a, and this will be 2x plus 4 minus of 2x plus 4, so that will be 0, and 2x plus 6 minus of 2x plus 6, so that will become 0, and then 2x plus a plus c, and this will be 2b minus of a plus c, sorry, this will be 2b minus of a plus c, and here in the third row we will have x plus 3, x plus 4, then x plus c. So the determinant of this, that should be equal to 0. Now if we expand this uh, determinant along the second row, since the second row has got most number of zeros, so we can expand this determinant along the second row. Therefore we will have that 2b minus of a plus c, so that multiplied by 2b minus of a plus c into b. So we have to remove the second row and the third column, so then we will have x plus 1 into x plus 4 plus 1 into x plus 4 minus x plus 2 into x plus 3. So this will be equal to, so this should be equal to 0. So it means we can write this is 2b minus of a plus c into this will be x. So this will be equal to x square plus 5x plus 4 minus x square minus 5x minus 6. So that is equal to 0. It means x square and x square will cancel, 5x and 5x will cancel. So 4 minus 6, that is minus 2. So therefore we can say that 2b, that should be equal to a plus c. So it means that a, b and c should be in AP. A, B, C are in AP. So option B is the correct answer. Then question number 15, it is told that if the matrix A, is given as 2 1 0 0 2 1 1 0 2, then the determinant of the adjoint of A, is how much? So we know that the determinant of adjoint of A, that is given as A raised to the power n minus 1. A raised, so it is determinant of A raised to n minus 1. Determinant of A raised to n minus 1, where n is the order of the matrix, where n is the order of matrix A. So n is the order of matrix A. Now here n, therefore here n is equal to 3, since 3 is the order of the matrix A. So now we have to find the determinant of A. Therefore the determinant of A, that will be equal to, we can expand this determinant along the first row. We can expand this determinant along the first row. It will be 2 into 2 to the 4 minus 0, then minus 1 into 0 minus 1, then plus 0 into 0 minus 2. So this will be equal to 8 plus 1, that is equal to 9. So the determinant of A equal to 9, but we have to find the determinant of adjoint of A. That will be equal to the determinant of A whole power 3 minus 1, which is the the determinant of A whole square, which is equal to 81. So 81 is the answer. So option B is the correct answer. Then in question number 16, it is told that if A and B are square matrices of the same order, A and B are square matrices of the same order, such that A plus B into A minus B is equal to A square minus B square, then AB into A inverse whole square is equal to. So A and B are square matrices of the same order. So A plus B into A minus B, that is given as A into A into A minus A into B plus B into A minus B into B. So which is equal to A square minus AB plus BA minus B square. So that is given as that is equal to A square minus B square. So it means what? So it means BA minus AB, that is equal to 0 matrix, means that is equal to null matrix. So it means BA is equal to AB. So it means that AB equals to BA. AB equals to BA we can write. So now if we multiply with A inverse on both sides, it means if we do AB into A inverse, that will be equal to BA into A inverse. So here what we are doing, we are post multiplying both sides by A inverse. Post multiplying both sides by A inverse. So post multiplying, it means that suppose if you do suppose if you do like A into B, so it means B is being post multiplied with A, or I can say A is pre multiplied with B. So the matrix which is written in front, that is called as the pre multiplier, and the second matrix is called as the post multiplier. So now AB into A inverse, that is equal to B into A into A inverse. So A into A inverse is equal to I always. So and I into B, that is equal to B only. So therefore AB A inverse whole square, that will be equal to B square. So option C is the correct answer. Now here in question number 17, it is told that if the determinant of 1 plus sine square theta and cos square theta and 4 sine theta 4 sine 2 theta, then sine square theta into 1 plus cos square theta, then 4 sine 2 theta, this is sine square theta, then cos square theta, that is 4 sine 2 theta minus 1. So that is equal to 0. And theta is greater than 0 but less than pi by 2. Then cos 4 theta is how much? And cos 4 theta equal to how much? That we have to find. So now if the determinant of this is equal to 0, theta is greater than 0 and less than pi by 2. So now here we can add first the first column and the second column. So if we add the first column and the second column, then we will have, we add the first column and second column here. If we do like C1, so this part I can remove. So we have to find value of cos 4 theta actually. Okay, then so we can add, we can tell that C1 goes to C1 plus C2. So then we will have, it means the column 1 is changed to column 1 plus column 2. Then we will have the determinant of 1 plus sine square theta plus cos square theta is 1. So 1 plus 1 is 2. Then here we will have cos square theta, here 4 sine 2 theta. Here sine square theta plus again 1 plus cos square theta, this will be 2. Sine square theta plus cos square theta, that is 1. This will be 1 plus cos square theta, and this is cos square theta, and this is 4 sine 2 theta, and this is 4 sine 2 theta minus 1. So the determinant of this, that is equal to 0. Then we can say that the determinant of, now here we can apply the row operation, that is R1 goes to R1 minus R2. We can apply the row operation, R1 goes to R1 minus R2. So then we will have, that is equal to 0, the determinant of, so 2 minus 2, that will be 0, and this minus this, so this will become minus 1, and these two will get cancelled. So this is 0 minus 1 and then 0. Then here in the second row we will have 2, 1 plus cos square theta, 4 sine 2 theta, then it is 1 cos square theta, 1 cos square theta, then 4 sine 2 theta minus 1, sine 2 theta minus 1. So this determinant will be equal to 0. So for now we can expand this determinant along the first row, since we have most number of zeros in the first row. So if we expand this determinant along the first row, then we will get minus of minus 1, that is plus 1 into, since this into this, so that is 1 plus cos square theta into 4 sine 2 theta minus 1, then that minus 4 sine 2 theta into cos square theta, so that is equal to 0. So therefore I can say this will be 1 into 4 sine 2 theta, so that is 1, so 4 sine 2 theta minus 1 plus 4 sine 2 theta into 4 sine 2 theta into cos square theta minus cos square theta, then minus 4 sine 2 theta into cos square theta, that is equal to 0. So these two will get cancelled. So here we can see that this will be, so that is 4 sine 2 theta minus, this is 1, so this is equal to, this we can again write 1 minus sine square theta, so this is minus 1 minus of 1 minus sine square theta, so that is equal to 0. This will be 4 sine 2 theta, 1 and 1 will cancel, sorry, it's not the case. Okay. So this will be 4 sine 2 theta plus sine square theta minus 2, that is equal to 0. So from here we can say that This is 4 sine 2 theta minus 1. This is minus cos square theta. Okay, so this will be 1 into sorry, this is actually wrong. That is wrong actually. So here actually we have to expand this. If we expand this determinant along the first row, then we will have 1 into, so we have to remove the first row and the second column, so it will be 8 2 into this, so it will be 2 into 4 sine 2 theta minus 1 minus it will be 4 sine 2 theta, so that is equal to 0. So then we will have 8 sine 2 theta minus 2 minus 4 sine 2 theta, that is equal to 0. So therefore we will have 4 sine 2 theta, that is equal to 2. Therefore sine 2 theta, that is equal to 1 by 2. So sine 2 theta is 1 by 2. So therefore cos 2 theta, that will be, so, or cos 4 theta has been asked. Find the value of cos 4 theta. So cos 4 theta is 1 minus 2 sine square 2 theta. That will be 1 minus 2 into 1 by 2 whole square. So that is also 1 minus 1 by 2, which is also equal to 1 by 2. So cos 4 theta is also 1 by 2. So option B is the correct answer. Then in question number 18, it is told if A and B are two square matrices of the same order, then and such that AB equals to B and BA that is equal to A, then A square plus B square is always equal to. So now A square plus B square. So AB equal to B. So we can say that AB into B, that is equal to B into B, that is equal to B square. And BA into A, that is equal to A into A, that is also equal to A square. So it means that A square plus B square, that is equal to AB square plus BA square. Means I can say that is equal to okay, sorry. So here you can solve it like this, that so A square, so A square plus B square. So A square is given as, A is written as BA, so I can do BA whole square plus B square, I can write it as AB whole square. So this will be equal to BA into BA plus this I can write it as AB into AB. So now this B into AB I can write B into AB into A plus this I can write A into BA into B. So now B into AB is B into B into A plus this will be A into BA is A, so this is A into A into B. So that is also equal to B square A. Now again BA that is equal to A, so that is B into A plus A into AB, that is again equal to B. So AB, So BA again, that is A, and AB is B. So that is equal to A plus B. So option A is the correct answer. Okay. Then in question number 19, it is told if A is a 3 cross 3 non-singular matrix, and if the determinant of A that is equal to 3, then the determinant of 2A whole inverse that is equal to how much? So it is a non-singular matrix. So the determinant of A is 3. So the determinant of 2A that will be equal to 2 power 3 into the determinant of A. So that will be equal to 8 into 3. So that is 24. So now the determinant of A 2A, we know that the determinant of B inverse that is equal to 1 by the determinant of B. Since why the determinant of B inverse that is given as the determinant of adjoint of A by determinant of A. So that is equal to the 1 by determinant of A whole power 3 into the determinant of adjoint of A. So now determinant of adjoint of A that is equal to, this is 1 by determinant of A whole power 3 into the determinant of adjoint of A is the determinant of A whole square. So this is 1 by determinant of, oh, okay, 1 by determinant of A. So therefore the determinant of 2A whole inverse that is equal to 1 by the determinant of 2A, which is equal to 1 by 24. So option C is the correct answer. Then question number 20, it is told that if the matrix A is 3, 2, 1, 1, then A square plus XA plus YI that is equal to 0 for X comma Y equal to how much? So what should be the ordered pair X comma Y? That is asked. So now A square means that is A into A, that is equal to the product of A with itself, 3, 2, 1, 1 into 3, 2, 1, 1, that is equal to the matrix first row into first column. So it is 3 3 is 9 plus 2, then this is first row into second column, so 3 is 6 plus 2, and this is first row second row into first column, that is 3 plus 1, and second row into second column, that is 2 plus 1. So that is equal to the matrix, this is 11 8 4 3. X into the matrix A, so that is X into, that is 3 2 1 1, so that is 3X, that is 2X, that is X, this is X. Then yi that will be equal to y 0 0 y, that should be equal to 0. So now therefore we have x square plus x a plus yi that is equal to 0. So it means that we have to add, so a square that is 11 8 4 3 plus xa that is 3x 2x 3x 2x and xx and plus yi, that is y0 0 y. Since y the is equal to y into the identity matrix, which is 1 0 0 1, so that is equal to the zero matrix or the null matrix, that is 0 0 0 0. So therefore we can say that 11 plus 3x plus y, that is equal to 0, and we can say that 8 plus 2x, that is also equal to 0. So it means that 2x equal to minus 8, so x is equal to minus 4. So therefore I can say 11 minus 12 plus y, that is equal to 0. So y is equal to 12 minus 11, that is equal to 1. So y is equal to 1 and x equal to minus 4. So therefore the ordered pair x comma y is minus 4 comma 1. So option B is the correct answer. Then in the next question, number 21, the constant term of the polynomial is, okay. So we have to find the constant term in the polynomial, which is expressed as the determinant of x plus 3, x plus 2, x plus 1, x minus 1, x plus 2, 2x, 3x plus 1. So if we have to expand this determinant, so we have to expand this determinant. So what we can do, we can so we can do column 1 goes to column 1 minus column 2, and we can do column 2 goes to column 2 minus column 3. Okay. So then, so if we do the first column operation, then we will have, that is equal to the determinant of, so let's call it as f of x. So therefore f of x will be equal to the determinant of c1 goes to c1 minus c2, so that is 3. This is minus 1, and this is x plus 2 minus 2x, that is minus x. And this is x minus x plus 1, 2x, x plus 2, x minus 1, and 3x plus 1. So here we are applying this column operation, and then if we apply this column operation, that c2 goes to c2 minus c3, then we will have 3 minus 1 minus x, and then so this is x plus 2 minus 2x. So this is 2 minus x. Okay, this is 2 minus x, and this will be x minus of x minus 2, that is x minus of x plus 2, that is minus 2. And then this will be x plus 1 minus x minus 1, that is also 2. This will be 2x minus of 3x plus 1, that is minus x minus 1. So this is x plus 2, x minus 1 into 3x plus 1. Simply the rule is that the constant term in the polynomial, if you want, we have to put f of 0. F of 0 we have to put. So now this here we can do again. So therefore f of 0 will be 3 minus 2, 2, minus 1, 2, minus 1, then 0, minus 1, 1. So then again we can, so if we expand this determinant along the third column, then we will have, this is a31, a32, a33. So this is minus of minus 1 into this row, and this row and this column we have to exclude. Then this will be minus 3 plus 2, and then plus 1 into this row and this column, third row, third column we have to remove, that is then 3 to the 6 minus 2, so this will be minus 1 plus 4, sorry, this will be minus of minus 1, sorry, this is 2 minus x, this will be 2. Okay. This will be plus 2 into, then sit the first third row and first column we have to remove, then this will be 2 into uh, 2 minus 4, so this will be minus 4, so this will be minus 1. So therefore the constant term in this polynomial is minus 1. So option D is the correct answer. Then it is told that the matrix A is given as cos theta sin theta, then minus sin theta cos theta. Then we have to find the value of A into A transpose. Now A transpose will be cos theta minus sin theta, then sin theta cos theta. So therefore A into A transpose, that will be equal to, we have to multiply these two matrices. So this is cos theta sin theta minus sin theta cos theta, and into this will be cos theta minus sin theta cos theta. This will be equal to, so we have to take the product of the elements of first row and first column. So this will be cos square theta plus sin square theta, that is 1. Then again this is minus sin theta cos theta and plus sin theta cos theta. Then this is minus sin theta cos theta plus sin theta cos theta, and this is again sin square theta plus cos square theta, that is 1. So this is 0, so this is 1 0 0 1, so that is equal to I. So option A is the correct answer. And then in question number 23 it is told, if this matrix is singular then the value of x is. So the rule is that if the matrix A is a singular matrix, the matrix A is a singular matrix, then the determinant of A, then the determinant of A should be equal to 0. So here the determinant of A, that is the determinant of 1 2 minus 1 1 x minus 2 1 x 1 1, that should be equal to 0. So therefore the determinant of, we have to take we have to expand this determinant along the first row. So this will be 1 into x minus 2 minus 1 minus 2 into this will be 1 minus x, then minus 1 into this will be 1 minus of x into x minus 2, so that would be equal to 0. So therefore be x minus 3 minus 2 plus 2x, then minus 1 into 1 minus x square plus 2x, so that is equal to 0. So this will be x plus 2x, that is 3x, then minus 3 minus 3, that is minus 6, then minus 1 plus x square minus 2x, it should be equal to 0. Therefore we can say this will be x square plus x minus 7, that is equal to 0. It's 3. So this will be so 1 into x minus 2 minus 1, then minus 2 into 1 minus x, then minus 1 into 1 minus x into x minus 2. So this will be x minus 3 minus 2 into plus 2x, then minus 1 into 1 minus x square plus 2x. This will be x plus 2x, that is 3x minus, this is 5. This is 5. 3x minus 5 minus 1. 3x minus 5 minus 1 plus x square plus minus 2x. Okay, so this will be x square minus x square plus x minus 6, that is equal to 0. So 2 3 are 6, so I can say this is x plus 3 into x minus 2, that is equal to 0. It means x can be equal to minus 3 or 2. So the value of x can be 2. So option A is the correct answer. Okay. Then in question number 24, it is told that if A and B are symmetric matrices of the same order, symmetric means A transpose equal to A and B transpose is also equal to B. Since why both are symmetric matrices and they are of the same order, then which of the following is not true? So A plus B is symmetric. So A plus B whole transpose is A transpose plus B transpose. So that is also equal to A plus B. So it means that A plus B is symmetric. So it is true. Now A minus B whole transpose, that is equal to A transpose minus B transpose, which is equal to A minus B. So A minus B is also a symmetric matrix. But AB plus BA whole transpose, so that will be equal to AB whole transpose plus BA whole transpose. So that will be B transpose into A transpose plus A transpose into B transpose. So B transpose is equal to B and A transpose is equal to A. Then plus this is A transpose is A and B transpose is B. So they are same, AB plus BA. So AB plus BA is also a symmetric matrix. So option C is also correct, means it is true. But AB minus BA whole transpose, it will be AB whole transpose minus BA whole transpose. So that will be A transpose into B transpose minus B transpose into A transpose. So A transpose is A, B transpose is B, minus B transpose is B, A transpose is A. Sorry, this is wrong. This part is wrong. So AB whole transpose is B transpose into A transpose, then minus BA whole transpose is A transpose into B transpose. So B transpose is B, so A transpose is A, minus A transpose is A, B transpose is B. So this is coming BA minus AB, which is equal to minus of AB minus BA. So it means that AB minus BA is Q symmetric matrix. It is Q symmetric, but it is written that it is symmetric. So option D is not true. So option D is the correct answer. Then in question number 5, it is told if omega is an imaginary cube root of unity, then the value of this is how much? Okay, so we know that omega cube is equal to 1 and 1 plus omega square, that is equal to 0. So we have to find the value of the determinant of, to find the value of the determinant of 1 omega square 1 minus omega power 4 omega 1 plus omega power 5 1 omega square. So that will be equal to, so 1 and omega square, and then this guy I can write as 1 minus omega, since omega power 4 will be equal to omega cube into omega, that is equal to omega, and omega power 5 is omega into omega cube into omega square, that is equal to omega square. So this will be omega 1 and 1 plus omega square, and this will be 1 omega and omega square. So this will be equal to the determinant of, will be 1 omega square and 1 minus omega, then omega 1, and then 1 plus omega square can be written as minus omega. This is 1 omega and this is omega square. So then we have to expand this determinant. So here we can apply the column operation, that is C3 goes to C1 plus C2 plus C3. Then we will get 1 omega square 1 minus omega and then omega 1. So C3, so this plus this, so this will be 2 minus omega plus omega square. And then here also I will have, this will be 1, this will be 1. So this is actually 1 plus omega square. So this will be 2 plus omega square. This will be 1 omega and this will be 1 plus omega square. So that will be equal to the determinant of, this is 1 omega square and this is 2 minus omega plus omega square. So this we can write it as, so 1 plus omega square, we can write it as minus omega. 1 plus omega square is minus omega. So this is 1 minus 2 omega. This is 1 minus 2 omega. Here I will have omega 1 and so this is 1 plus omega square is 0. So this is 1, this is 1 and here this will be 1 omega and 0. 1 omega and 0. So now if we expand this determinant along this third row, then we will have 1 into omega square minus of 1 plus 2 omega. Then minus omega into, we have to remove third row and second column. So this is 1 minus omega minus 2 omega square. This is 1 minus omega plus 2 omega square. Then plus 0 into something is 0 only. So then this will be omega square minus 1 plus 2 omega minus omega plus omega square minus 2 omega cube. So this will be 2 omega square, then plus omega, 2 omega square plus omega minus 1 minus 2. This will be omega plus 2 omega square minus 3. So which will be equal to, so omega plus omega square, I can write omega plus omega square is minus 1. So this will be omega square minus 1 minus 3. So that is omega square minus 4. So omega square minus 4. So option B is the correct answer. Then in question number 26, it is told if G is equal to the set, okay, so it is a group. So X, 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 X. So it is the matrix X, 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 where X is a non-zero real number. So X belongs to R minus 0. So is a group with respect to matrix multiplication. In this group, the inverse of this is inverse of this. Okay. So here let let the identity matrix in this group be, let the identity matrix in this group G, this group G be A, B, C, D. So then we can say that any matrix X, 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 X into this identity matrix A, B, C, D, that should be equal to that matrix only, X, 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 X. So it means that we can say that this is X into AX plus CX, so A plus C into X, and this will be B plus D into X. Then this will be again A plus C into X, and this is B plus D into X. So that is equal to X, 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 X. So it means that A plus C that should be equal to 1, and B plus D that should be also equal to 1. So therefore we can take A, and A, B, C and D that should be the same. So A equal to B equal to C equal to D it should be. Since A, B, C and D also should belong to the group G. A, B, C and D should belong to the group G. That's why A, B, C and D they should be equal. So each should be equal to half. So therefore the identity matrix is, therefore the identity matrix in the group G, identity matrix in the group G is, the group G is half, half, half and half. So now the identity matrix into this matrix, that should be, it means we know that A into A inverse that should be equal to I. So now if we take the matrix X, so X, 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 X into A inverse, so let the A inverse, let A inverse be also like, like say it is EFGH. So into EFGH, that is equal to half, half, half and half. So actually all of them should be same, so you should take them like n. Suppose we take the A inverse as n, the n, 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 n. So this is n, 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 n. So it means what? That nx plus nx. So 2nx. Nx plus nx. So 2nx. Here also 2nx, 2nx and 2nx. That is equal to half of half of. So therefore 2nx that is equal to half. Therefore nx that should be equal to 1 by 4. So now therefore the inverse of 1 by 3, 1 by 3, 1 by 3 and 1 by 3. So now here x is, means that x is 1 by 3. So that will be, so now n into 1 by 3 that is equal to 1 by 4. So therefore n should be equal to 3 by 4. So it means its inverse will be equal to 3 by 4, 3 by 4, 3 by 4 and 3 by 4. So option B is the correct answer. So then in question number 27, it is told that the determinant of sine alpha, cos alpha, sine alpha plus delta, then sine beta, cos beta, sine beta plus delta. This is sine gamma, cos gamma, and then sine gamma plus delta. That is equal to how much? So now we can expand this actually. So then we can write it as the determinant of sine alpha cos alpha, then this is sine alpha cos delta and plus cos alpha sine delta, and then this is sine beta cos beta, and this is also sine beta cos delta plus cos beta sine delta. This is sine gamma cos gamma, and this is sine gamma cos delta plus cos gamma sine delta. So it means that what we can do, we can do C3 goes to C3 minus sine delta into C1 minus cos delta into C1 minus sine delta into C2. So this if we do, then we will have, this is sine alpha, this is cos alpha, and then this part will get cancelled. Since why, if we do cos delta into C1, then this part will get cancelled, and sine delta into C2, so this part will get cancelled. So this will become 0, then sine beta cos beta 0, then sine gamma cos gamma 0. So it means all the elements in the third columns are 0. So therefore the value of the determinant will also be 0. If we expand this determinant along the third column, then the value of the determinant also will come 0. So option A is the correct answer. Then in question number 28, it is told that if f of x equal to the determinant of sine x cos x tan x and x cube x square x 2x 1x, then limit f of x by x square, limit x tends to 0 f of x by x square, that is how much. So we have to multiply x square with 2. We can either multiply with 1 by x square with a single row, or with 1 by x with one row and 1 by x with another row, or we can do 1 by x with the first column and 1 by x with the second column. So therefore f of x by x square, that will be equal to, that I can do sine x by x and x cube by x, 2x by x, then this is cos x x square 1, and this will be tan x by x by x by x, and this is also x by x. So therefore this is coming sine x by x, and this is coming x square, and this is 2. This is cos x x square 1, and this is tan x by x. This is 1, this is 1. So therefore limit x tends to 0 f of x by x square, that will be equal to, so we can apply limit x tends to 0 in only one of the rows. So we have to apply limit x tends to 0 in all the elements. So that will be equal to the determinant of, now limit sine x by x is 1, limit x tends to 0 cos x is also 1, limit x tends to 0 tan x by x is also 1, and limit x tends to 0 x square is 0, and this is 0, this is 1, this is 2, this is 1, this is 1. So that will be equal to, now if we expand this determinant along the third row, then we will have, since it has most number of zeros. That will be 1 into this second row, third column. So this will be minus 1 into, then we have to remove the second row and third column. So this will be 1 minus 2. So this is 1. Okay. So limit extends to 0. So this is minus 1 into, so limit extends to 0. So when I put x equal to 0, so this is coming 0 actually. This will come 0. So we can do f double dash x divided by 2. So we can do f double dash 0 divided by 2. So now f double dash x, that will be equal to, so this is cos x, this is minus sin x, and then dx of cos x is minus sin x, so this is minus cos x, and then this is secant square x. Okay. So here so if we put x equal to 0 here, so this is coming 1. So option A is the correct answer. Then in question number 29, it is told inverse of a diagonal non-singular matrix is. So inverse of a diagonal non-singular matrix is. So suppose, for example, if I take like the matrix 2, 0, 0, 3, 0, 2, 0, 0, minus 3, suppose. So if this is matrix A, then A inverse will be how much? A inverse will be equal to, so this is 2, we have to remove. This is A11, A12, A1, A21, A22. So so these are the cofactors. A11 will be, this is minus 3, and A12 will be first row, second column. So this is 0, and A21 is second row, first column. This is again 0. Then A22 will be 2. So this is again a diagonal matrix only. So inverse of a diagonal non-singular matrix is a diagonal matrix itself. So option A is the correct answer. Then in question number 30, it is told that if ax power 4 plus bx cube plus cx square plus dx plus e, that is equal to this, that is equal to x cube plus 3x and x minus 1, x plus 3, then x minus 1 minus 2x, then x plus x minus 4, then x minus 3, then x plus 4, then 3x is this, then e is equal to how much? Okay, so e is the constant term in this polynomial. So constant term in this polynomial we have to find. So it means simply we can put x equal to 0. Put x equal to 0, then we can find out e. E is the constant term, so it can, so if you tell this is f of x, then e is simply equal to f of 0. So if we put x equal to 0, then we can find the value of e. So that will be equal to 0, minus 1, 3, 1, 0, minus 4, minus 3, 4, 0. So therefore this will be, we can expand this determinant along the first row. Then this will be 1 into first row and second column we have to remove. So this is 0 minus 12. Then plus 3 into first row and third column we have to remove. So this is 4 minus 0. So this will be minus 12 plus 12, that is equal to 0. So option C is the correct answer. Then we have to find the, so it is told that the characteristic equation of a matrix is this. Then the adjoint, or then the determinant of the adjoint of A is how much? So the characteristic, we know that the characteristic equation of the matrix A, is given as the determinant of A minus lambda I, that is equal to 0. Now therefore here it is told that the determinant of A minus lambda I, that is equal to lambda cube minus 5 lambda square minus 3 lambda plus 2. So now we know that the determinant of adjoint of A, that is equal to the determinant of A whole power n minus 1. So here we are having three characteristic roots of the equation. We are having three roots of the characteristic equation, three characteristic roots. So it means that matrix A is of the order 3 cross 3. So therefore n should be equal to 3. So therefore it will be the determinant of A whole power whole square. Determinant of A whole square. So we have to find the value of lambda here. So here we can see that minus 2 is a root. Since y minus 2 whole cube minus 5 into minus 2 whole square minus 3 into minus 2 plus 2, that is equal to minus 8 minus 20 then plus 3 is 6. Okay, okay, so here so we have to find the determinant of A. So here the product of the roots, product of the roots product of the roots is minus 2. Product of the roots is minus 2 and sum of the roots is 5. Suppose we have the matrix A as like suppose it is a diagonal matrix. So suppose I can tell it will be A 0 0 0 B 0 and 0 0 C, and so this minus we have to do lambda 0 0 0 lambda 0 0 0 lambda. So A minus lambda I. So this will be A minus lambda 0 0 0 B minus lambda 0 0 0 C minus lambda. So the determinant of this, that will be A minus lambda into B minus lambda into C minus lambda. That should be equal to 0. The determinant of this will be 0. This will be equal, this will be the characteristic equation. This we can write lambda minus A into lambda minus B into lambda minus C, that is equal to 0. Now the determinant of A, that will be equal to actually ABC. So it means we have to find the product of the roots. Since here lambda can be A, B and C. A, B and C are the characteristic roots. So it means that the product of the roots only is the required determinant of A. So here also the determinant of A will be equal to the product of the roots, which is minus 2. So therefore the determinant of the adjoint of A, that will be equal to the determinant of A whole power 3 minus 1, which is minus 2 whole power 2, which is equal to 4. So option A is the correct answer. So now then in question number 32, it is told that if A and B are matrices of order n such that A square minus B square, that is equal to A minus B into A plus B, then which of the following will be true? So it means that A minus B into A plus B will be A square minus A square plus AB minus BA plus minus B square, that is equal to A square minus B square. It means what? It means that AB should be equal to BA. AB should be equal to BA. Means option C is the correct answer. So here we shall end the first part of this chapter on matrices and determinants. So here we shall end the first part of the video on matrices and determinants, and hope you have understood all the steps of the solutions of all these 32 questions. So if you are unable to understand any of the steps of the solution, then please write us in the comments section, and any other chapter, if you feel it is difficult for you, then please write us the name of that chapter in the comments, and please install our Sapience education application, whose link has been provided in the description. So thank you everyone. Bye.